Hello everyone and welcome to our deep dive into React's useEffect hook. Today we're going to explore everything from the basics to advanced use cases, common pitfalls, and best practices. Whether you're new to React or looking to polish your skills, this video will provide valuable insights into one of React's most powerful hooks. Let's start with the basics. The useEffect hook is a tool in React for handling side effects in functional components. Side effects are operations like API calls, manipulating the DOM, setting up subscriptions, or timers. Unlike render methods or React components, side effects don't fit into React's declarative nature. Here's a basic example. In this snippet, useEffect is used to update the document title every render. This is a side effect because it interacts with the browser's DOM, which is outside the scope of our React component. Looking at this example, it demonstrates how to make an API call using the useEffect hook. It fetches data from the fake API endpoint and stores it in the component state. On another example, you can see how to use useEffect to set up and clean up subscriptions. This example simulates a simple event subscription. And on the last example, we show setting up a timer using useEffect. It updates a counter every second. Now let's talk about the dependency array. This feature of useEffect lets us control when our effect runs. By default, without a dependency array, our effect runs every render. However, we can optimize this by specifying a list of values the effect depends on. Here, the effect only runs when count changes. It's crucial to list all dependencies accurately to prevent bugs and ensure our component updates correctly. One critical aspect of useEffect is the use of empty dependency arrays. This approach tells React to run the effect only once after the initial render. It's similar to the component did mount and component will unmount lifecycle methods in class components. Here's an example. In this example, the effect runs once when the component mounts, and the cleanup function runs when the component unmounts. This pattern is useful for setting up subscriptions, event listeners, or any other operation that needs to happen once and only once during the lifespan of the component. Now let's talk about cleaning up effects. In React, managing side effects efficiently is crucial for building robust and performant applications. Certain side effects, such as event listeners, subscriptions, or timers, can lead to memory leaks and other unwanted behaviors if not properly handled. This is important in single-page applications where components frequently mount and unmount as users navigate through the application. React's useEffect hook provides a built-in mechanism to handle such scenarios effectively. In this code, the effect runs a cleanup function. React calls this function when the component unmounts or before rerunning the effect due to a dependency change. The cleanup function removes the event listener, preventing potential memory leaks and ensuring that the event handler does not get called after the component has unmounted. And now let's cover some common pitfalls. There are several common pitfalls with useEffect. One major mistake is mismanaging the dependency array, either by leaving dependencies out or including too many. This can lead to unexpected behaviors. Another issue is creating infinite loops by setting a state within an effect that triggers the effect itself. It's crucial to understand the timing of effect execution to avoid these issues. In looking at our infinite count example, as you can tell, we will both set count in the effect, and then anytime count changes, we'll rerun the effect, essentially causing an infinite loop. Now let's go over advanced use cases. In advanced scenarios, useEffect can be used for operations like data fetching, context, debouncing, throttling, or interacting with external libraries. Here's an example of fetching data, and this shows async data fetching inside useEffect. Handling loading states and errors is also crucial in these cases. Another one is useEffect in the context API. useEffect can be used in conjunction with the context API to perform side effects in response to the context value changes. This is useful in scenarios where you want to synchronize your component side effects with changes in your application state that is managed by the context API. Here's an example of useEffect and how it can be integrated in context. And in this example, my component consumes a value from my context. The useEffect is used to perform a side effect whenever the context value changes. This pattern is helpful for keeping components in sync with the global application state, allowing for a more modular and manageable state management. Then there's debouncing. Debouncing is a technique that delays the execution of a function until after a certain period of time has passed since it was last called. This means the function will only be executed after the user has stopped a certain activity for a predefined amount of time. Here's an example of implementing debouncing in React component with useEffect. The effect updates debounce value only after the user has stopped typing for 1 second. And then we have throttling. On the other hand, it ensures that a function is executed at most once every specified period. This is useful for controlling the rate at which a function is executed. Here's an example of implementing throttling in a React component. Throttle value is updated at most once every second as the user types. Both debouncing and throttling in useEffect can be crucial for optimizing performance and enhancing user experience in applications that require real-time data processing or API transactions. And now let's cover integrations as far as external libraries. We'll cover D3. D3 is a popular library for creating complex data visualizations. React, however, manages the DOM in its own way, which can conflict with the D3's direct DOM manipulation. useEffect allows you to safely integrate D3 with a React component. Here's an example of useEffect. And in this example, D3 is used to create an SVG element for a bar chart. And useEffect ensures that this visualization updates whenever the data prop changes. In our other example, a more popular one, we are integrating with jQuery. And jQuery often manipulates the DOM directly, like D3, which can be problematic in React app. With the useEffect, you can ensure that jQuery plugins are initialized and destroyed correctly in line with the component lifecycle. In this example, a jQuery plugin is initialized on a DOM element, and useEffect is used to clean it up with the component unmounts, preventing memory leaks or unintended side effects. In both cases, useEffect acts as a bridge between React's own ecosystem and external libraries, ensuring that the external code integrates smoothly with React's component lifecycle and state management. This pattern is crucial for maintaining optimal performance and avoiding conflicts in more complex applications. Some best practices for useEffect include keeping effects focused on a single task, using multiple useEffect hooks for unrelated logic, leveraging custom hooks for reusable effects, and always including dependency arrays for clarity and preventing future bugs. To sum up, understanding useEffect is key to mastering React. It allows us to integrate our components with non-React code like browser APIs, timers, or even external data sources. I hope this video helps you to use useEffect more effectively in your projects. Thank you for watching, and please feel free to leave your questions or comments below. Don't forget to like, subscribe, and check out my other content for more web development tips and tricks.